ओके, हाय रेकॉर्डिंग स्टार्ट केला म्हणजे झाला स्टार्ट.
Okay, then fine.
पण ओके, हाय स्टार्ट केला पण लेट सी लाईक हाऊ इट वर्क्स. बट ओके, इट हॅज स्टार्टेड. आय डोंट नो इफ साऊंड डज नॉट कम इन दी एंड, बट ओके, but okay, I've tried. But
घातले
if
घातले
if someone has some other device, no, they can also record what is important, voiceover also, how the meeting y'all can
Okay,
hear.
okay. Okay, wait.
So that also can be done. So because you, I don't believe that you all have to go through the PDF. You all can understand, yeah, what I'm trying to explain.
हांगा मरे तू तुजो सगळो पार्ट एक्सप्लेन कर हां.
Uh, okay, so I have taken more efforts in, as I said, in this. What is there in my
स्क्रीन
PDF?
दिसना.
What is there in my PDF or my chapter? I have
Share
given
this.
a. Okay, okay.
स्क्रीन दिसना जाणं.
Screen na this now. Okay, okay.
आता दिसता.
Okay. I hope you all can see my screen.
येस.
Okay, so I have also given what the whole chapter is about. Okay, in my first paragraph tells what the whole chapter is about. Okay, it is about chance theory. Now, what is chance theory? All the 5 chapters, let me again tell you all, it is about decision making and reasoning and logic. That is why I have put it in bold. Okay, that is the primary goal of every topic. If we are not using thinking or decision making or reasoning, we can't move with anything. Then only it will become, probability will become number of events upon the number of outcomes upon total number of outcomes. Only that will become probability. It will have no meaning in itself. That is why I have told. Now I have also mentioned the Bonsignier's problem. There is nothing called Bonsignor. It is Mad Hatter's problem. He is a person with a hat who is a bit of a psychotic person. So that is why I've given him a name that is Bonsignor. Okay, Bonsignor प्रॉब्लमान काय ना इतले जे तुमका डिफिकल्ट चलतले असे. फक्त 2 केसी अज्युम केल्या. Bonsignor is a smart thinking person. He will tell you, or he will try to disguise you, okay, or he will try to manipulate you by telling you that the price may be in this box or that box or vice versa, or the price may not be there. So it is up to Jane whether she sticks to her decision or she changes. If she had chosen the proper box where the price was there, and if Bonsignor told her, take this box in which the price is there, she changes her decision, finds out that Bonsignor cheated her or manipulated her, then her decision is wrong. Or if she stands by her decision stands right. He may also genuinely help someone by telling that, okay, I may tell you just like in Kaun Banega Karodpati 50-50. Okay, someone wants to join. Okay, so the Bonsignier's problem, it is only about decision making and how changing or switching to a decision will lead to an outcome. Only that factor is involved. Rest, there is nothing involved here. Okay, it is only a decision making process. Probability of 2 by 3, 1 by 3, and probability 1. These are the only 3 numbers that are being played, and probability 0. Okay, now in my third paragraph, I have mentioned that our probability theory is only an art of giving some logical answers. Okay, is a way of giving bad answers to problems which have worse answers. Okay, so as I mentioned earlier, probability is ideal. We say that, okay, probability is 0.75 or 0.5 something or 0.25, but that has no meaning. Okay, in practical life, probability probability in other way has no logic. Only it has logic when you are considering one chance out of 1,000 or 10,000, then it makes sense that the probability is almost zero that I am selecting something. Otherwise, when two dice thrown or a coin is tossed, probability is half and probability is 1 by 6. It is very rational. You cannot give a conclusive answer. That is why I have mentioned this. Probability theory or chance theory gives you only somewhat a probable answer. It does not give you an exact answer to something. Then I have mentioned the Parcheesi game, which is at the heart of the current chapter. Okay, to be honest with you all, there is nothing rocket science involved in this chapter, but only the Parcheesi game is something that I saw that nobody has taught us from school, at least for me, from my school, junior college till the bachelor's degree, nobody has taught me this. So I took this game because at least someone who reads the project will think like this, that okay, something he has taken that I have also not come across. At least I can say this. That is why I took this. Otherwise, all other things are covered in our lower classes. Any doubts or anything? Any clarifications? Hello?
No, sir.
Okay. Okay. So the Bonsignior's mind games, I have given this purposely the name mind games. Okay. Bonsignior, there are three boxes involved here, and one contains a prize. And Jane always chooses box two. Okay. And Bonsignor always sees that one of the box is opened and he finds it to be empty. And then he allows Jane to change her mind. Then what must Jane do? That is a question here. It is also a theory and it is also like a problem. So I will not explain the entire thing because it may take 1 hour to explain all this only, and some of you all may switch off after some time, okay, mentally. But what I want to tell this, there are three boxes and he helps you. Someone comes and helps you and tells you the prize is not in this box, only these two boxes are involved. Then what a logical person will say who has not studied? He will think in these terms that okay, he has opened one box, two boxes are remaining. So the probability that my answer is correct or if I have made the right choice is 50% because one box is already gone. So only there are two choices, that is box number 1 and box number 3. So my probability of winning is 50%. But no, how we are looking at the Bonsignior's problem? We are looking at the probability of losing. And after looking at the probability of losing, then we are coming to the probability of winning. That is one way of looking at Bonsignior's problem. Example, when you go to compete, you don't check your probability of winning in a race. Example, if there are 10 people, if you all see how you all will think in practical life, you all will always keep an eye on those people who are better than you, who are comparatively better than you. And once you eliminate those people, then you will say, ah, now I am in the picture of winning the race. So we are looking at probability because nobody will ask you all to draw boxes and tell you all what is the probability of winning and losing and what are the. He may ask you all like this something. He may not tell you all to draw something on the board as far as I see. So I will not waste time on something that is not required. So he may ask you all, one question that he may ask you all is how do we look at probability of losing? Now the catch here is, the main catch is, Bonsignor knows in which box the prize is. He may purposely try to manipulate you. He knows that you have chosen the right box. So he may tell you only to make you lose. He may tell you of this box, okay, which I am telling you. And you may fall for his temptation and choose the wrong box, knowing already that you all had chosen the right box. So in this case, you all will lose. Okay. In the other scenario, he may open a box in which there is no prize and he may tell you change your decision if you want to. And the box which you have already chosen, box number 2, did not contain the prize. You all may choose box number 1 because he has opened box number 3. So in that case, you all will win and your probability of winning is 1. Okay. So we are looking at probability because how the probability is 1 now. It should be 1 by 3, no? So how it is 1? Because he has opened one box for you. So one possibility he has erased. Plus he is giving you certainty that the box you have chosen is a wrong choice and that he is giving you a second chance. So that is why you are eliminating the box number 2 which you have already chosen and you are going for box number 3 or box number 1 rather, sorry. So you are eliminating these two possibilities of losing. So you are left with only one possibility. So your probability of winning is 100%. That is how we look at cases. Any doubts, please let me know. I stopped for few seconds.
No.
Now please look at these diagrams. There is something called optimal move or to stay with the move that you have chosen already. Double lines and single lines are mentioned. Okay. So when you change your decision or you remain or stick to your original decision, if the price was already in the box and you chose the other decision or you switched your decision, you will lose because he manipulated you. If you had chosen a wrong box or in which the price was not there and then you changed your decision, then you will win because he is really helping you. So Bonsignor is not a certain player. He is only helping you, but his help is not certain. Example, how can you apply in real life? Okay, the decision making process. I'm not talking about Bonsignor's mind games, but decision making process. Someone will come and tell you that in a bunch of example, 100 students, you need to top the class. So what you will do, you will find your probability of coming in merit, that is 1 by 100. No, nobody will do that. You all will only look at those 5 to 10 students who are brilliant, or you may look at, if you are an average student, you will look at those 20 to 25 students who are doing or faring off better than you. And then after eliminating this 20-25 people, then you will come in the merit list. You don't have to start from people or compare yourself with people who are below average. So this is how it works in real life. We eliminate the competitors and then we come in the bunch of the trivial top position people. This is how chance theory or decision making theory is applied in real life. So just look here at the last second line. I have put P prime A, P prime B, P prime C. Okay. I thought sir will mention it as an error, but he did not mention, hopefully. So because probabilities can never be zero, because probabilities, we consider probability, as Shambhavi said, we consider an event only when we can proceed with something. If the probability of an event is zero, then we don't have to consider only the probability because it is not there existing only. Example, if I say I toss a coin, and if neither head comes or neither tail comes, can this happen? It cannot happen. So why do I have to consider it in the first place? So I can say that is a probability P prime A, that event. Okay, that is why I mentioned these probabilities as ideal probabilities. When events A, B, C are exhausted, means they never happen only. So that is why I mentioned there probabilities are never zero. Because when you get probability of an event 1, that means all other events are exhausted. Now, okay, this is something that I've done on my own. You will not find in the book. Okay, I've considered ideal scenarios. Probabilities are 1 by 3. I don't know. It is at the start of the game. Bonsignor intervenes and he tells that box number 3 is empty. Then what I will think ideally, it is in box number 1 or 2. A, B, C are boxes 1, 2 and 3. The probability is PA, PB, PC. Probability that price is in box 1, 2 and 3. So it is 1 by 2. Then chances game plan. Now let me be clear. Chance is a mythical player. Now you all will think that there are only two players in the game, that is Jane and Bonsignor. Jane, she is actually playing the game, and Bonsignor is like a coach who is trying to help her. But there is a third player known as Chance. Now, how it is a mythical player means it is not a player in real life. Why Chance is a real player? Because, or a mythical player, sorry, because he has decided the outcome before the game has started. Because Chance himself has put the prize in one of the boxes. It is just like a treasure hunt. I hope you all have, some of you all have participated in some games like treasure hunt. I am the chance player because I have kept the so-called hidden treasures on particular places. And then I tell you all the participants to play. Now, why I am a player? I may put the prize somewhere where you all cannot find. So I know you all will go on searching endlessly and I will not get the prize and you all will not get the prize. Okay? Or I may help you all. I may tell you all that okay, I am reducing your location to this area, specific area. You all can go there and try to search the hidden treasure. Then I am really helping you because I already know the outcome of the game. I am the main player here. So that is why, though I am not actually participating in the game, that is why I am a mythical player chance. Then I have put cases. Chance's game plan. What it is, I will not explain all the things, but what is Chance's game plan is that he is putting the prize in box 1 and then the outcomes are decided. This is only theory, there is nothing more practical, okay? It is only theory. That is why he has put so probability is 1. That means P prime B and P prime C are 0. That means these two cases are exhausted. That is why they are mentioned by P prime. Now, I already said you are looking at probability of winning based on the probability of losing. Okay, P prime of C is 0 and is P prime B is 0. She wins. Why? Because one choice was already exhausted out of 3 and her probability of winning therefore will be 2 by 3. 1 minus 1 by 3. Because I am looking at a probability of winning based on the probability of losing. Similarly, there is a second option that the prize is in box 3. Similarly, you have to proceed with that. I will not explain everything here. And then the third, there are only 3 cases. You all have any doubts? Please let me know. I'm stopping for few seconds.
सो हाजो कन्क्लुजन कितें की जेनान तेजे डिसिजन चेंज करप की ना
ना
म्हणजे
आम्ही दर केसेस घेतले हांव. We will take all cases. We will eliminate probability of losing. Probability of losing is the probability of finding those boxes in which the prize is not there. Bonsignor is helping us. Bonsignor is telling us whether the prize is really there or it's not there. Also, I have considered one more case, okay? Bonsignor may by chance open a box. I consider two cases where he may help you. How he will help you? Okay, Shambhavi, I'm answering your question in a bit elaborative way. Sorry for that,
ओके
yeah. But the probability, how he will help you, he will actually tell you that switch your decision by telling you in which box the prize is not there. Like example, box 3. Or then he may tell you, he may manipulate you telling that if he already knows that you have chosen box 2 and the prize is already there in box 2, he may tell you switch your decision and he will open an empty box. Okay? But there is a third possibility. Third possibility is that he will actually open a box in which prize is there. He may actually open a box in which prize is there. That is whichever box. Example, if it is box number 2. Then Bonsignor in this case is actually helping you with how to proceed with the game. And actually he's telling you that you have made one wrong choice and he's telling you this is your second choice, you can opt for this choice. He's actually helping you and he's not manipulating you, because in this scenario, this is an ideal scenario. If someone is trying to help you in something, either he will cheat you or he will either try to genuinely help you. You cannot expect someone to come and help you who does not know what is actually. Like example, take Kaun Banega Crorepati. Nobody will come and help you who does not know the answer. Either he will tell you I don't know the answer, or he will tell you this is the actual option. Opt this. Nobody will come and tell you that I am not sure, but you opt for this. He cannot do that. This is an ideal scenario. So Bonsignor may actually open a box in which the prize is there. So Shambhavi, answer to your question is we are eradicating or we are eliminating those events in which the prize is not there. And then we are switching to an event of winning based on how many options are left. If two boxes are opened and prize is not in both those boxes, that means my probability of winning would have been those two events 2 by 3 is exhausted. So my probability of winning is 1 by 3 in that one box. Got it, Shambhavi? We are okay. I may, because I am very fast, I may say something vice versa, but just read through it. Main point is look at probability of losing, eliminate that, and then conclude the probability of winning. That is the answer. It is only a decision making
Okay.
process. Yeah,
Okay.
hello?
So we have to select all the probabilities, all the chances, and neglect the probability of losing and
Yeah,
see the probability of winning.
winning. Yeah, correct. That is the main point.
Okay.
Okay, we should eliminate factors and then come to a decision. That is the main thing idea. There is nothing, no rocket science there involved. Okay, now you all
सो
will,
ते बॉक्स तीन हॅलो
yeah,
तीन
continue.
बॉक्स आसात तर तितलो एका हातून दोन चान्सीस आसात ते तो करेक्ट सांगता वा रॉंग सांगता हय मरे
हय तर मागीर ते दोन एलिमिनेट
तशें
केले की कितें रावले मेन डिसिजन ते
एका
आमी
बॉक्सान करेक्ट आसा 1/3 तशें
करेक्ट करेक्ट
ओके
करेक्ट two boxes are opened and both are empty. That means two boxes are opened and both are empty. That means the probability of winning will be, of course, it was trivially 1 by 3, but now the probability of winning will be what?
1
See, look at this line here. Jane holds on to her decision. Okay, she had selected box 2, that is probability of price in box 2, that is a p of b, that is 1. That means what? P prime of A is 0, P prime of C is 0, because she made a correct decision. As Jane holds on to her decision, as box 3 is opened, P prime of C is 0, because Bonsignor opened this box 3, and P of B is 1. She had already made a correct decision, so she wins. And as she made only one choice out of the three, because she said, Bonsignor, I don't want your help, I will stick to my original decision. That is why her probability of winning will be 1 by 3.
हा ओके सपोज ते ताची हेल्प घेता जाल्यार चेंज जातलो आन्सर
चेंज जातलो.
हा ओके ताची
हा
हेल्प घेता म्हणजे
हा
एक बॉक्स वतलो एलिमिनेट जातलो सो दोनूच बॉक्स उरतले
हय म्हणून हे कन्क्लुजन दर हाका दिल्यात. तुम्ही जर पळयशात तर तुम्ही खंयचोय बूक उगडा तो तांचे एक्सप्लेनेशन हय एंड जाता. लेट मॅथमॅटिकल एक्सप्रेशन्स एक्सप्लेन, थंय एंड जाता ताचे. हांवें जे हे सोल्युशन घाला सकयल ते हांवें मजे एक्सप्लेन करून घाला, so that there is a conclusion in every part. See, these three lines are very important. These three lines are very important, so at least read those. I may say something in a hurry which is vice versa. Okay, I may make mistakes, but you all please read through all this. It is only a decision making process and how probability changes on decision. Okay, I think I was okay enough to explain with that part. Now there is probability of dependence and independence. Okay, this is something from 12th standard. Okay, there is nothing, no rocket science involved.
We've done this part, no?
Yeah,
So
we
it's
have already
okay.
done. Yeah, probability of dependence and independence. Okay, this you all have done. SCC also you all have done. I remember, Miss Vikita. Yeah, I don't have to explain all this. Now only Look at the last three lines. Two independent events. The probability that both will occur simultaneously is equal to the product of the individual probabilities. That is, probability of A intersection B is equals to probability of A into probability of B. That only you all will have to recall. Based on only this, probability of A intersection B is probability of A into probability of B. We have a new subtopic that is called chances induced with fallacies. Okay, you all can open any book and check. There is no problem like this, and it is not something very complicated problem. It is very simple. Even a 10th standard student can understand this problem, only this problem. So I have made up this problem. It is very simple, and someone will say why this has come also in the project. It is not required. But I may not be able to explain with you all where I take 500 options and where the probability of winning is 1 by 500 or 2 by 500. You all will not understand how the logic is applied. But if I take tossing of a coin, then you all will understand. I put it as a word problem. So you all will understand what happened wrong and what went wrong in decision making process. So that is why I put this the topic as chances induced with fallacies. Means something going wrong. One factor that we are missing, something going wrong. This is also very trivial solution, everything I have mentioned. And this you all won't find in any other book. Okay, I am not saying that I have made a research and I have done this, but you all will find something similar. But this I have tried to make as my own problem. Like how should we think? What happens when we take two events? Probabilities of those individual events is P of A plus P of B. P of A union B. But what we are forgetting is A intersection B. So that is what is coming in the picture in the last three lines. And I have given the reasoning. Okay. Usually when combinatorics is also the book, if you all see, it begins with a very simple example. And then it catches speed. Then you will have to really struggle. And when you come at the end of the chapter, you will say in 7 to 8 pages, it becomes like dimag ki maa behan ho gayi, like that it will become. So there is another problem here, which is a bit little complicated. Complicated only with values. So here we have given probabilities that what will happen in this scenario. This is also based on the similar logic what we have applied. Now what I want you all to focus is on the second paragraph. Probability of union is not sum of the individual probabilities, because W1 and W2 can occur simultaneously. Okay, that means W1 intersection W2 is not phi or empty. He may win in both the lotteries. If I am playing in two lotteries, there's a higher chance of winning. But it may happen that I may win in both those lotteries, luck by chance. So that is why we have used the logic. Okay. You all have any difficulty in this? I don't think so, but if you all have, let me know. And it is based on a second logic, that is probability of A intersection B is probability of A into probability of B. This law is coming into picture. Okay, probability of A intersection B is probability of A into probability of B. That law is coming into picture. If I take the probability of winning as Q, other will be 1 minus Q. So that law is being applied. Probability of W1 intersection W2 plus W1 intersection L2 plus L1 intersection W2. And I am coming with two answers. Okay, look at the last two paragraphs. Same answer using two separate logics. One, I eliminate, as I said in Bonsiner's problem, eliminate the probability of losing, you will get a probability of winning. That is happening in the second scenario.
Jonathan,
Yeah,
hello.
yeah,
Alright, you applied the formula like probability of winning plus probability of losing equal to 1. That formula you have applied, no, in that
yeah.
last line.
Correct, correct.
Okay, okay.
Hmm. Correct. Yeah. Now, okay, anybody has any doubt?
No, proceed.
Okay. Okay. Gambler's logic, no. It is very simple. Gambler's logic is very trivial. Now, okay, example, everything is based on one logic. That is, look at this remark. If you all have nothing to do up in life, example, and if you all say that, okay, I will conduct a game. If the probability of an event in a game is A, then the bookie will earn some profit if the winner is allotted the prize which is less than 1 times the probability, the amount he paid. Okay, that is the whole thing on what this is based. It is very simple. You all can read and you all can understand. I don't think I have to explain anything. Example: if I am a bookie and if I have a die, okay, simple one, not those IPL ones or whatever, not those gambling and betting ones, but a simple one. You all come to me and say that, okay, and I tell you all have to pay 1 rupee each to play the game. And if you all win the game, if you all tell me exact number which is coming up on a die, then I will give you all 7 rupees. And if you all pay me, then will I gain some profit? Hello?
Yes.
How will I gain some
Repeat,
profit?
repeat.
Okay, I am
No.
conducting a game. Okay, I am repeating for the benefit of all. I am conducting a game and I am telling you all that, okay, pay 1 rupee to participate in the game. And I am throwing a die. You all have to tell me the numbers from 1 to 6, which number will turn up. And if you all tell me which number comes up, you all will get $7 or 7 rupees. So I, as a bookie, because I am sitting there and conducting a game, I must also gain some profit. No? Otherwise, why I am doing this? So will I gain some profit or no?
No.
How many
No.
participants are there?
There are 6 participants. Only 6. Okay, we are.
Yeah, so no
Oh,
profit.
okay,
Yeah.
No
no,
profit.
then no.
Huh.
Then no.
So this is all based on this logic. Okay, I gave you all the simplest case of 1 rupee and 6. Okay, I made one idealism here that each player can participate only once and each player can only opt for one separate number. Example, if example 6 people come and they say that, okay, number five, and if by chance number 5 comes, should I give 7 rupees to everyone? No. Then what I will get? No. So in this case, I will gain no profit. Now, how that logic? You can sum up the logic here. What is the probability of he winning? Is 1 by 6. Okay, the probability of winning in the game is A. A is 1 by 6. So what will be 1 by A? 1 upon 1 by 6. That is 6. 6 into the amount he paid. What was the amount he paid? 1. So if I give him something less than 6 rupees, then only I am gaining some profit. But in this scenario, I paid him 7 rupees. So I am at a loss because the income that is coming is 6 rupees and I am paying someone 7 rupees. So I am paying 1 rupee from my pocket every time, whatever the outcome comes. But if I say, take the similar case, and if I say, if you all win, I will give you all 5 rupees or 4 rupees, then will I gain some profit? Yes. How? Put in the formula. 1 rupee, that is the amount he paid, into probability. Probability is 1 upon 1 by 6, that is 6, which is less than 4, or 5 is less than 6. So then only I am getting some profit. But 7 is not less than 6. 7 is not less than 6. Yeah, correct. So the pigeonhole principle, like that. So this is based on that. So this is a remark which is very simple, but I have just tried to make it as a remark. So
A is the probability of that event, right?
yeah, in a particular game.
Yeah, so it is 1 upon the probability, that is 1 upon something.
1 upon 1 by 6 in this arc scenario, that is 6. Yeah.
Yeah, correct.
Hmm.
So that 6 will go on top and therefore it will be that thing. Understood.
Okay. So all these other paragraphs you all read. Hell will freeze, I have written in this case, hell will freeze in italics. What it means, that I will sit and I will make a loss for myself. Hell will freeze means I will make a loss. Means example I gave you all 7 rupees I am paying you all. Actually I'm getting income 6 rupees and I'm paying you all 7 rupees or 10 rupees example. That means hell will freeze means I will be at a loss. That is the meaning of the phrase, nothing else. I have copied it from the book. Now compound lotteries. Compound lotteries, I have explained in a video what is a compound lottery. Compound lottery is very important because compound lottery is used in purchases scenario. Okay, I will not speak anything of this because this is a direct example from the textbook. Someone had a question, what is L and M? They have already defined what is L and M. Okay, I have not done anything here. Sir also mentioned what is the that please mention what is the big prize $24. You have 5 chances in every 12 possible outcomes. Okay, so he told me to mention what it is. The lottery M has 3 prizes. I will say that there are 1 to 12 numbers each one, and you have to open a chit. Example, how you play, like when you were small you used to play chore police, like that. And if those 5 special numbers come, example say 2, 3, 5, 7, 9, then you will get some price, that is $24. It is already defined. Okay, I am not defining anything. So then what is important here is the probability, compound probability of summing up of two independent events happening simultaneously. Let me give you all what is the example. Please listen to this example. This is not in the book or my PDF. There are two coins which are placed in front of you. Okay, there are two coins which are placed in front of you, and there is a bag of 10, you can say 10 boxes, small boxes. Now you have to select one of the two coins and toss them. Okay, but to reach those two coins you will have to go through this bag. Means you have to play whatever this event is of choosing a box from a bag. Now someone tells you, can you tell me the probability that a tail comes up from coin number 2? Similar example I have mentioned, coin number 1 and coin number 2. But when I go reach there, I have to make a choice whether to select coin number 1 or coin number 2. So I have two possibilities. So how to make this simple? I will put 10 boxes, as I said, in a bag. 3 boxes will be colored green and 7 boxes will be colored red. Please listen, it is very simple. And someone will tell me, please select one box, and the fate of which box you decide will decide which coin you choose. Example, there are 3 green boxes. If one of the green boxes you choose comes up, which you cannot see in the disposable bag, so then you may have to go to coin 1. But if one of the red box comes up from the 7, then you have to go to coin 2. So what are two things which are in front of me? There are two levels. I have to go to that bag and I have to ensure that only one of the red box comes. So what is the probability? 7 by 10. Once that 7 by 10 comes, I have to go to coin 2. And now someone has already asked me that I want a particular outcome, that is head or tails of that coin number 2, not coin number 1. So then again there is a 50% chance when I toss that coin that I will get a probability of 50%. So that is why I will have to multiply the probability, that is 7 by 10, of choosing coin number 2, and then probability, that is 1 by 2, that is half, of getting a head or tail of coin 2. Got it? So that is how the probability, compound probability, is involved. That means outcome of one depends on the pre-outcome of something else. Like example, it is like this: semester 6 and semester 5. Simple examples. If and only if you clear semester 5, someone tells you, then only you can attempt semester 6. So you have to ensure that you clear all the 5 papers of semester 5. That is probability 1 by or whatever, 1 by 5. After doing that only there's a probability that you will go to semester 6 and then clear 1 by 5. That probability is 1 by 5. So example, you want to clear, someone gives you a condition that if you fail in one of the subjects of semester 5, you cannot attempt a specific paper. That is an example, matrix spaces example, just to make it clear, nothing like this. So I have to ensure that I have clear all the 5 papers of semester 5. Probability is 1 by 5. And then after doing that only I will go to semester 6, and then only I can make a decision that I have to clear that matrix space. What that is probability again will be 1 by 5 because there are 5 more papers involved. Someone will say, yeah, it is not choosing the papers, but yeah, I will just see of clearing the papers. Once you clear one paper, you can move to the other. So this is how compound probability has been applied, the logic. So you all will see here how compound probability is applied. Again, I have made a video. If you all want, again, I will make a short video how compound probability can be applied. So now we are going to the main topic, that is the last topic of Parcheesi. Any doubts? Any doubts? All are there in the meet? Or if I am there?
No doubt, no
Yes.
doubt.
Okay, no
All
doubts.
there.
Proceed.
Okay, no doubts. Okay, just listen to the first paragraph, first line. Parcheesi is an infinite game, only that much. Can someone answer why it is an infinite game? Actually, it is an infinite game.
पार्चेसी म्हणजे कितें?
Hello?
पार्चेसी म्हणजे कितें?
Okay, let me give you all a brief history of Parcheesi. Parcheesi was a game played during Akbar's time. It was a game similar like Ludo, what we play in today's modern world. But Ludo is something different. How Ludo begins? Can you all tell me how Ludo begins? Okay, I will not waste time. If an outcome 6 comes, then only my counter comes out from the 4 counters that I have, correct? Then
Yes.
only I can proceed. Then only I can proceed. Example, how Ludo can become an infinite game. Example, if two players are playing, okay, with 4 counters. Counters means what we call them as pyada or whatever you call them as, like, yeah,
Gulio.
the moves. Yeah, the moves. Okay, the counters. So how can Ludo become infinite? Ludo can become infinite if 6 neither comes from anyone. Means I am tossing a, means I am throwing a die. All numbers are coming from 1 to 5, but 6 is not coming up. Like example, if Shambhavi is playing with me, she is throwing a die and 1 to 5 is coming, but 6 is not coming. So the game is not beginning only. म्हणजे आम्ही सासनांक उरतले होतय. That is why it is called an infinite game. Answering your question, Preeti, Parcheesi is similar like olden Ludo. Only the difference is that there are 3 exceptions. One thing is, instead of a die, a coin is thrown. In a Ludo, what you can do is, you can either take 1 step to 6 steps based on the number. But in Parcheesi, you can only take 1 or 2 steps. These are mentioned, okay, in the paragraphs. Please read through those. I will not waste time. That is one difference. Second major difference is, in Ludo, what happens when a number comes and once our counter is out, we will go further. But in Parcheesi, what we can do, we can decide that I will not move my counter. I will stay where I am. I will not move my counter. So that is an exception. So that is a second exception of a Parcheesi. So I have explained what is Parcheesi. Parcheesi is similar like Ludo, only that a coin is involved. The outcome is involved, or how much we. Otherwise, everything is same. If my counter lands on your counter or on the same path, you will go back to your original position. But in Parcheesi, what happens? I'm not sure that much, but okay, what we are referring here is only one counter is involved. We are not looking at 4 counters or 6 counters. But in Ludo, that is happening. Ludo, we are having 4 counters. So even if my one counter goes back home, I have other 3 counters to look after. But not in Parcheesi. Parcheesi, if one counter goes, that is why it is called simplified Parcheesi. One counter is involved of both. Okay. and it is an infinite game. What happens if both? That will never happen, and that term we eradicate. That is why I've mentioned it clearly in the paragraph within short lines. The main idea is to convey maximum information using less number of words. So Parjezi can become infinite if, example, Saish and I, we both are playing, and whatever comes, I decide that I will not move my counter. Saish, he will throw, he will toss a coin and he will say, I am not moving my counter. We will remain there only for eternity. So that is why it is an infinite game. Any doubts? See the see the two diagrams A and B. We are looking at B, that is simplified. Only we have to go to three positions. And if you see A is like a actual Ludo, actual Parchesi Ludo. Okay, now they have given four figures like, okay, there's an owl, there's a crab, there's a girl, okay, whatever, the four players, okay, just for representation. Why we are, okay, someone will ask you, examiner will ask you, why you have taken simplified Parchesi? Any answer? Any answer someone can give me?
Otherwise, that game will be infinite. No, simplified participation. Our aim is to win the game. Is that the
No,
answer?
your answer is somewhat okay, but okay, it is not that much what I am looking for. Why we are looking at simplified Parchesi? Simplified Parchesi can also become infinite. Look where actually black is placed and white is placed. Both of us will decide, Saish and me, that whatever comes on a coin, head or tail, will not move our counters. So this also will remain infinite. So what is the catch here? What is the logic? This is how we must think. The examiner will question you all back. Or if the examiner has not gone through the project thoroughly, then he may say, okay, okay, no problem. But okay, someone will think like this and ask you question back or question you back. That this is also infinite. Nobody will move their counters. Then why your question is not logical? So then why it is simplified? Because we only look at six counters, and the second ideal assumption is that when a coin is tossed, we will move a counter. When a coin is tossed, initially we will move a counter. We will not say that we will remain stuck to one position eternity. Someone will move the counter, at least one. If white decides to move, he will reach. And if black says that I am remaining at the same place, then he will lose. So that is why. So the main answer should be, your answer should be, why it is simplified. Now look at the combinatorial meaning of what is simplified Parchesi. How many boxes are there? How many positions can be occupied? If you all see, there are 8 positions which can be occupied. Black can be at the first box, second box, or the third box, not at the fourth box, otherwise he will win. Similarly, white can occupy the other two positions. So the total positions, independent positions that can be occupied are 2 raised to 3, that is 8. 8 positions, independent positions can be applied. Use the combinatorial meaning, what we have studied. That is why we are getting 8 equations. Please keep this in mind. We are getting 8 equations on different positions, Parchesi positions, and then we are proceeding. Why we have taken simplified Parchesi? For otherwise take a normal Parchesi, that is A. Okay, picture number A. There are so many boxes. Based on so many boxes, we will have so many number of positions. Then you will have to multiply 2 raised to something 16 or 17. So that many equations you will get, and then that many equations you will have to solve. Then you will remain for all eternity because so many moves are possible. But when I only look at the 6 positions or 8 positions, sorry, 6 boxes or 8 positions, then I can only deduce 8 equations and I can solve them. That is why we are only looking at simplified Parchesi. We are not looking at the entire outcome of Parchesi. Nobody has up till now tried to look at the entire Parchesi. Example, the same logic can be applied to the game of chess, but there are higher equations involved of higher powers. So that is why you can also Vishwanathan Anand or Mark Carlson can sit and they can deduce equations and they can say that which move is optimal and what is the probability of winning. That also they can do if they are mathematicians. and chess players at the same time, but it will take all eternity to solve that many equations. And one is dependent on the other equation, so you'll have to deduce all those things. That is why we are looking at simplified Parcheesi. Let me be clear, I don't think examiner will ask you all to solve all the 8 equations, so don't get into all that, but at least he may ask you all solve some trivial equations. Any questions? Any questions? Yes, no, don't know.
No.
Okay. Okay, these 8 positions are directly derived using combinatorial meaning. Okay. But even if you all draw 6 boxes and just if you all use logic, because this is a small number, you all can derive equations. And position 1 and 2 are trivial, that winning is applied here directly. You can give any other variable. In case the examiner tells you, just explain me the 8 positions of Parcheesi, then you can draw these positions. Okay, he may or he may not ask you all. He's just interested in asking you all what are the dynamics of the game. He's not interested in asking you all to solve. He may ask, I am always using the word may. Anything may come up. Something may come up that I have not covered also, or something which I don't know also. It may be a surprise for me and for you all. So be prepared for that also. But okay, these are the positions. Now, okay. Now, our aim is to find the value of f. Okay, just see the last 3 lines. But f is dependent on a, b, c, d, and e. The values of a, b, c, d, and e. Now see, the position f is position number 8. Now why I have to find the position, or why I have to find the value of f corresponding to position 8? It is because from here the game is beginning. This is an ideal position. Both are starting from the same place. If you see the first 7 positions, one has the advantage over the other. Position 1, position 2, white has complete advantage over black. So he will win. In position 3, 4, 5, 6, 7, one black may have advantage over white or vice versa based on what is the value of A, B, C, D, and E. But F is an ideal position. It is like both players are starting a race from the same position. So it is like what speed he should use and what speed white and black they should use to win the race. So like that it is in similar analogous position. So that is why we want to find the value of F. Now second thing to note down is we are always starting this with someone has to start a game, no? So we are assuming, and there is nothing without loss of generality, we are assuming that white is starting the game, not black. So white is making the first move. So this is the position 8 corresponding to the first move corresponding to white. So if the value of F is more than 1 by 2, 50%, that means white has a better chance of winning. If F is less than half, then black has a major chance of winning. It is like 2 players are competing. If my probability of winning is 60%, that means I have advantage over someone else and vice versa. Now someone may ask you the question, why is position 9, 10, 11, 12, 13, 14, 15, 16, why these are not considered? We don't need to consider them because these are analogous positions. When I say that, okay, we are coming to an outcome of a game, someone has to start the game without loss of generality. Once you find the values of A, B, C, D, E, and F, all other things will, by substituting, you will get the values of 1 minus A, 1 minus B, 1 minus C, and vice versa. Okay. Okay. Now this equation I have explained in my video. I am very clear how I have taken that. Now now I am not interested in explaining all the values here, but just look at this box. We cannot do anything with position number 1 and position number 2. There are no parameters involved. The advantage is very clear that white will win. I have taken position 3. Why I did not take position number 6, 4 or 5? Look at position number 4.
Jonathan,
Yeah.
एक्सक्यूज मी हातूंतल्यान वीन जाता कितें तें कशें कळटा?
हातूंतल्यान
हय,
win,
फ्रॉम द
win.
फिगर.
Win,
या.
proper figure of winning is position number 8. Okay, y'all can scroll in your PDF. Why it is position number 8? Because I am looking something called as induction. Induction is not mathematical induction, what we have studied, is moving to one step from some previous step. Okay, there are three equations in three variables. And if I know the value of one variable, I will substitute in equation number 2. After doing that, I will get to value of two variables. Then I will substitute it in the equation number 3, and I will find the value of all three variables. So it is induction. One step is leading you to the other step. The main term of induction is this. I find P of 1. Then from P of 1, I assume P of k. And then I assume it proof of P of k plus 1. So in the process,
Yeah,
what
yeah.
I'm doing, I'm moving from one step, one at a time. 1, then from 1 to k. It is like a horse problem. And then k plus 1. So like that it is. Probability win कशी जाता कशे कळता आम्ही फाइंड करूंक जाय व्हॅल्यू ऑफ एफ. आता एफ व्हॅल्यू कित्याक ते पोझिशन अशें आहा जंयच्यान दोनूय प्लेयर सायमल्टेनियसली खेळोंक सुरू जातात. एफ ची जर व्हॅल्यू मोर दॅन 0.5 हा म्हणजे मोर दॅन हा तर म्हणजे एफ जिंकतलो. मीन्स इट इज लाईक दिस. Shambhavi has probability of winning 60% and me 40%. That means what? Shambhavi has some advantage over me. So in case I assume that Shambhavi is winning the game, probability is ideal, okay? The whole concept of probability is ideal. I cannot say that Shambhavi is winning 100% and I am winning 0%. If that is a scenario, why I have to play the game? I don't have to play only. I am not there only in the picture only. It is like a tail ender Bumrah in cricket trying to hit 200 runs. It is of no use. He cannot bat that much. So it is like that. He does not come in the competition only, first of all. So probability can be something from 0.1% to 0.999 something. Okay, that is what when two players are competing. Otherwise, probability of one is 0 or someone is 1, then I don't have to consider the other player only, because I know vice versa, he will win or he will lose. So the probability of what we have to do, the aim is to find the value of f. Both are starting from the same position. And that will be the probability of winning for white, because it is white's turn to move, because white is making the first move. Okay?
Okay.
Okay, now my second question.
Okay.
The examiner will ask you all something. Okay, this is one of my, I will soon end within 4-5 minutes, my whole thing. Why I cannot take position number 8 or position number 7? Keep in mind there are 8 positions. Based on 8 positions, we are getting equations. I have explained how we have considered position number 3. Please apply the same logic and move ahead for all the other positions. Okay, I cannot do it. Will take 1 hour and you all will get bored. But okay, why I have taken position number 3 first? Because why I have taken position 3 and not the other? Can anyone answer? I can start from position number 8 also and try to form equations. Okay, I will cut down the
So
chase. Yeah, tell me, Saish.
position has 1, 2, 3 and 3 unknowns, and
Yeah,
position 3 has only one.
yeah. Position 3 has only two unknowns, maximum two unknowns. And if you see position number 8 has D, F, E. So there are at least three unknowns. And okay, second reason is when I'm whether head comes up or tail comes up, let me revise once again. That is probability 1/2. But deciding to move or to wait, that is an optimal move. That is not a probability. Okay, because tossing a coin is not in our hands. Anything may come. But whether to move or to wait, you cannot say it is a probability. If second player is involved and if he's deciding whether to wait or to, that is a probability because it is not in your hand. But if you are deciding something, you will opt for maximum. Like example, it is like this: a question paper has come and two questions are there, option A or B. You will definitely attempt which you know. You will not attempt which you don't know, and you will say that okay, and then cry. No. So it is an optimal move. But this is not in our hand. Whether, like, for example, Gajanan sir's paper, that option B comes, which is very difficult, which you can't solve only, and you have to attempt, then it is not in our hand. So there's a 50% chance, like that it is. So I have tried to form equation 1. A will be compound probability of half into 1. Why not half into 0? Because we are only looking at optimal boxes, the top 4 boxes in which I am winning. I will never opt for a position from where I am losing. I will definitely opt for a position from where I am winning. See, white is already in the shaded box. He has won the game. That is why I will take the probability of winning as 1. If I decide to wait, my turn is lost, and black, whatever comes, head or tail, and the last rule has an exception that you can move one place, whatever comes up, head or tail. So he will definitely move and he will win. So my probability is 0. Why will I allow him to do that? So that is why I will choose half into 1. And in the second case, it is half because head may come or tail may come. Compound probability. Half into 1 minus d. Similarly, logic, I will not take 0. And then I will form a simultaneous equation with a and d. That is my first logic. Now see, now I can go to position 6. Why I can go to position 6? Because look at boxes number 2, 3 and 4 on top. I will definitely select half into 1 minus d. That is my compound probability of selecting one move. And each come with a fair probability 1 by 2. I will not select something that is 0, 0, 0. And in the last option, if you see that if tail comes up for position number 6, whether I move, whether I wait, I will lose. So I have to decide something. It is like a batsman just swinging his bat when he has nothing to lose. He will have to just connect and hit the ball, like that it is. He knows he will not win the match from here. So you can select any of the options, but half into 0 it will again eradicate. So I will get d is equals to half into 1 minus d. That equation I will form. Then after using that data what I have, I can substitute in equation number what I have already formed from position number 3. After finding a and d, I can go. Now if you see position number 5, position number 6, position number 7, position number 8. Now it is clear. If you see boxes number 1 and 2 of position number 2, 1 is always greater than 1 minus b. Okay, it is very clear. 1 is always greater than. So I will select my optimal move will be to move when head comes up. So I will select half into 1. But now it is 1 minus a and 1 minus b in box number 3 and 4 if tail comes up. Now whether to move or to wait, now I already found what is the value of 1 minus a, which is 1 by 6. Whether to move or to wait, I will have to look at the value of 1 minus b, and then I will have to consider two cases. If 1 minus b is greater than 1.6, then I will decide to wait. And if 1 minus b is less than 1 by 6, then my optimal move will be 1 by 8, which is 1 by 6, because this is a greater probability. And then I will decide to move. So I will have to take all these cases and then come to contradiction.
Jonathan,
Yeah,
please explain that last position 8
position 8.
last.
Position 8. Okay, I am just giving you all pointers. I can't go with equations. Okay, it will take a lot of time. But okay, when you all read, you all have to keep in mind what I've tried to explain. Now, okay, it is very clear. 1 and 1 minus b. 1 is greater. That is very clear. 1 is greater than or equal to 1 minus b. Even if b is 0, if I have taken 1, it is not a problem. But if in 1 minus a and 1 minus b, I have to consider two cases because I don't know. 1 minus b is unknown parameter. So 1 minus b can be greater than 1 by 6 or less than 1 by 6. My probability game is to win. So I have to consider a move or to wait, whether in every scenario based on what is the probability. If the probability of 1 by b is 1 minus b is greater than 1 by 6, I will go for that move because my aim is to win the game. Why will I opt for some probability where the chances are less of winning? So like that it is. Now, okay, similar logic, you all have to go with position 5, 6, 7 and 8. You all have to consider cases, the main aim. Please don't get scared. Nobody will tell you all to explain and write equations, everything. I don't think any examiner will do that. I doubt whether the examiner who sits, if it is not from our department of mathematics, it will be so trivial for him to understand all these equations and write without seeing. He may look and he may understand, okay. So don't get worried. Only you all have to consider what is the main aim. Finally, position 8. If you see at position 8, Saish told me to explain this. Here f is involved. So I will have to consider the cases of 1 minus f. 1 minus f is coming in the second box and the fourth box, each corresponding to heads and tails. So I have to consider two cases again. If 1 minus f is greater than 2 by 3, then I will decide to wait when head comes up. And if 1 minus f is greater than 3 by 4, then I will decide to wait when tail comes up. And if less than it is 2 by 3 and 3 by 4, so, okay, and vice versa, then I will decide to move. So I have to consider those cases. Let's go to position 8. Now that is step 5. That is step 5. If f is less than 1 by 2, I already said value is to find the value, aim is to find the value of f. If f is less than 1 by 2, then white should steal black's optimal strategy. Why? Because black is winning. Because if f is less than half, then what will be? See, f is less than half. Okay? Where did the equations go? Okay, so then 1 minus f will be greater than half. But then these are the position when it is black's turn. So all the moves I should correspond to analogous positions. They should be of black, which is of actually was of white. It should be of black because 1 minus f will be greater than half if f is less than half. If f is less than half, then white should steal black's optimal strategy by refusing to move at his first turn. Remember, the game began with we trying to make an assumption that we make a first move. How we have made a first move? Let me come back to the equation. See, a is equals to half into 1 plus half into 1 minus d. Half into 1, just remember, plus half into 1 minus d. Half into 1, see position 3 again. Half into 1, that means I am not waiting, I am moving, I am making my first move. I don't know whether what is coming, compound probability. So I am making a move because the probability of winning is 1, half into 1. So I should not move at my first case. You must always use the contradiction here or a contrapositive. It follows that f will be greater than half, and so 1 minus f will be less than half. Okay, if f is less than half, then white should steal black's optimal strategy. Okay, don't worry, even if you don't understand anything from this, I will make a video and send again. Okay, but by tomorrow, not today. And then we can form equations using position 8. F is equals to half into 1 minus d plus half into 1 minus e. Come back to position A. F is equals to half into 1 minus d. Because what I have considered, I can only take two possibilities. 1 minus f is less than half. Half 2 by 3 is greater than half or no? 2 by 3 is 0.66. Am I correct or no? 2 by 3 is 0.66. Yeah, correct. 0.66. And 1 minus f is less than half, means 1, it is less than 0.5. So I will select 1 minus d. Similarly, second box, 3 by 4. What is 3 by 4? 3 by 4 is, okay, 4 parts of 3, that is 0.75. 0.75, which is always greater than 0.5, 1 minus f. Okay, I'm just telling you all verbally. I can make a video if you all want. So that is why I will select 1 minus e, half into 1 minus e into half into 1 minus d. And I have already found out the values of 1 minus d and 1 minus e using similar logic in the previous days. So that is why I will come to the solution that f is equals to 17 by 24. And then you all can find the value of 17 by 24. That is the probability of winning for white. So then you can conclude what will be the winning probability. So that it is Pachesi. Okay, I have explained for 1 hour 10 minutes. I don't know how many were active, but okay. I have tried what I can do non-stop. Yeah.
Thank you, sir.